Okay, so I'm just going to go through B for this question. So calculate the concentration of the acid. All right, so the first thing we need to do is write down the balanced equation for this reaction. So we've got magnesium metal reacting with hydrochloric acid. And when we get a metal and an acid reacting, what we get is a salt. So in this case, it's magnesium chloride. Magnesium is a 2+ ion. Chloride is a -1. So my formula is magnesium to 2 chloride. Okay. And then we get hydrogen gas. So a salt and a gas. Okay, so we need to balance this. So here we've got 2 chloride, so I'm going to have to pop a 2 there. And the 2 hydrogen here is balanced by the 2 hydrogen here. So that's all balanced now. So what the question's saying is that at the beginning, this much magnesium was placed in hydrochloric acid. A reaction happened, bubbles occurred. These are the bubbles, the hydrogen gas. When the magnesium strip was removed, its mass was that much. So what this is telling me is that 2.56 minus 0.350 grams of magnesium has been lost because it reacted. So that's what we're interested in, that difference there, so 0. Okay, so that's telling me that 2.21 grams of magnesium reacted with the hydrochloric acid. Okay, but the question's asking me what the concentration of the acid is. So this is what we want information about. So I've got a gram value here, and for me to use my formula at all, I need to convert to moles, because this equation shows me a molar ratio. So 2.21 divided by the molar mass of magnesium is 24.3. So the amount of moles that I have of magnesium reacting is 0.09 moles. So that's how much is reacting. So how much would react with that many moles of magnesium? How many moles of hydrochloric acid? So hydrochloric acid, therefore, is my unknown mole value that I want to find out. So then I take the coefficient of my unknown, place it over the coefficient of my known. That's my molar ratio. I multiply by the mole value that I do know, which is that much. So the moles of hydrochloric acid, which are reacting, is double 0.09, which is 0.18. So that's telling me the moles of hydrochloric acid that are reacting, that have reacted as 0.18, okay, moles of hydrochloric acid. Okay, so, but the concentration, it's asking me the concentration. So concentration is moles per litre. So moles over volume in litres. So the concentration is 0.18, concentration of hydrochloric acid. The volume, now the volume was 200 mils. That's how much hydrochloric acid we had. So we know all the hydrochloric acid is used up because no more bubbles were produced and we had some excess magnesium. So all of these moles have been used up. Anyway, so that's the amount of moles of hydrochloric acid we've got. The volume was 200 mils. This volume has to be in litres, so we divide that by 1,000, which is 0.2. Okay, so when I divide that, my concentration is 0.9 molar. So that is basically how to figure out that question. If that still wasn't clear, just let me know. Okay.